Hello, this is Charlene. We're going to be talking about similar triangles today. The most important things we need to understand about similar triangles is that all their angles are equal to each other. The sides are not equal, but they are proportional. In this box right here, it specifically says corresponding angles are equal. And it also says that the ratio of their corresponding sides are in proportion. So the word corresponding is very important to this. If you look at these drawings of these two triangles right here, this is like the longest side is proportional to the longest side, and the shortest side is proportional to the shortest side, and the middle length side is proportional to the middle length side. Um, Going forward, we will also see other triangles set up in different configurations. Specifically, we'll see that they are similar even if one is rotated, even if it is a mirror image of the other triangle, or sometimes they will be embedded inside of the other. So we'll be looking at some situations that are similar to those three descriptions. Let's keep moving forward and just dive right in. Okay. So we've got this two sets of triangles. It says find the missing length x. So the missing length x, technically, they're calling it h, which is the height of this flagpole. But we've got two triangles created. We've got a man standing over here, and this man is 5 feet tall. We do not know the height of the flagpole, but we do know the length of their shadows. The man has an 8-foot shadow, and the flagpole has a 24-foot shadow. But what is true about these two triangles is that they are similar. We can compare the two shadow sides and the two heights in order to find the height of the flagpole. So again, we create proportions. That is key. Sides are proportional. So we're going to um, compare the man's height to the man's shadow. So that's what we're going to do first. And then we will set up another ratio. It will be the height of the flagpole related to its shadow. So I've already written it up for us over here. Okay. Bigger than I wanted it to be. There we go. So again, we have to understand that we are setting up ratios equal to ratios and a ratio equal to a ratio. It's a proportion. So we've got the man's height right here is 5, and his height is related to his shadow. And the height of the flagpole is related to the shadow of the flagpole. Once we set up a ratio equal to a ratio, and of course, another way to think about that is a fraction equal to a fraction. So we've got a fraction equal to a fraction, which is the same thing as a ratio equal to a ratio. And when we have a ratio equal to a ratio, that is a proportion. Once we have a proportion set up, then that means that we can cross multiply. You only cross multiply across the equal sign. So when we cross multiply, we're going to end up with 8 times h is equal to 5 times the 24. And then we're going to divide out that h on both sides. And that makes the 8 disappear. And then h is going to be equal to that calculation. And according to our calculation that I've already used on a graphing calculator, I'd multiply the 24 times 5, I get 120, divided by the 8 gives me 15. So the height of the flagpole is going to be equal to 15 feet. So 15 feet is the height of the flagpole. Height of flagpole. Okay. But I also need you to understand that we can actually set this up differently. We can also set it up where we do it, we compare some other things. So we can do 24 divided by h. When would I do 24 divided by h? Okay, so 24 divided by h, that is the shadow is still related to the flagpole. And 8 related to 5 means the shadow is related to the height. So we've basically turned these fractions upside down, and that's okay. What I need you to understand are just keeping things lined up. For this first one that we worked on up here, it was the vertical to horizontal. So this is a vertical number, and this is a horizontal number. So this was the vertical number, and the height is also vertical of the flagpole, and the shadow is a horizontal distance, and 24 is a horizontal distance of the shadow. And then we also, in terms of small to big, so all of these numbers right here have to do with the small triangle, and all these numbers here have to do with the big triangle. So just keeping things lined up, and that's if you can get comfortable with setting these things up. It's like if you do small to big, then all of these need to be about the small triangle. And all of these need to be about the big triangle. And the vertical, all the numbers on top would be the vertical numbers, the distances going up and down, and all the numbers in the denominators will be the horizontal numbers. So I know this seems like a lot of information right now, but I just want you to understand that there is not just one way to set up these ratios. You can set it up as long as you keep things straight in your mind. For instance, on this other setup, we're going, instead of going from small to big, we are actually going from big to small. So all of these numbers have to do with the big triangle. This is the big triangle, and this has to do with the small triangle. So we can go either way, and also the horizontal and vertical. The top numbers in the bottom proportion, the top numbers are horizontal numbers. That's the shadow lengths. And the bottom denominator numbers are vertical lengths going up and down. But anyway, we're going to keep going and learn some more about this. This next problem has a set of triangles that are actually embedded in one another. So we're going to, I've already got it set up here. And we're talking about the slanted side. So here is a slanted side. That's the slanted side of the small triangle. However, the slanted side of the big triangle is not just 10, it's 5 plus 10. That's the big triangle. So I've got a big triangle here, and I've got a little triangle here. So I've got to understand that the big slanted side is actually 15. It's going to be 10 plus 5. So the whole slanted side of the big triangle is going to be 15. And purple over there is not really working, is it? Okay. So, so I'm going to set up my ratios to be the slanted side. So this is going to be a slanted side and a slanted side. So 5 is related to 15 across the top. Slanted, those are all the slant sides. And the bottom is going to be the horizontal. So we're going to compare the x to the 15. So x to the 15. So all the numerators are slanted sides. All the denominators are horizontal sides. And then from the top, we can see that we're talking about the small triangle. All these numbers, 5 and x, 5 and x have to do with the small triangle. And these are the big triangle numbers, 15 to 15. Let me kind of erase that so we can see it more clearly. Okay, so I've got the big triangle here, and I've got 15. It's 15 is related to 15. So the slant side of the big one is 15, and the horizontal side is also 15. Okay, so again, we've set up a ratio equal to a ratio, and that means that we can now cross multiply. So when I cross multiply, I end up with 15x is equal to 5 times 15, and then I'm going to divide out 15 on both sides. And so x will be equal to the 5 because, of course, this 15 and this 15 will cancel. And, of course, it is also confirmed by our calculator. 5 is the answer. So that means that the x is going to be equal to 5 right there. The x will be equal to 5. But we can also set this up again um, differently. We can set this up where all the numbers on top are the small triangle. All the numbers on the bottom are the big triangle. And all these numbers are horizontal numbers. There's the x is a horizontal number. The 15 is a horizontal number. And the slanted numbers are 5 and 15. So the slanted numbers are 5 and 15 for the big triangle. But when we cross multiply this set of ratios that are equal to each other, we still end up with 15x is equal to 15 times 5. We still divide out the 15, and we cancel out the 15s. All the 15s go away. So x is still equal to 5. So as long as you keep things straight, there are different ways to set up your ratios. And so the answer to this one, x is equal to 5. Next problem says that we are to find the height h meters in the following diagram at which the tennis ball must hit so that it will pass over the net and land 6 meters away from the base of the net. Okay, so if you don't play tennis, you might have to think about this a little bit to figure out what what they're describing to us. So I'm going to fast forward this. Basically, the net is going to be right here. This is where the net is going to be. So we're going to hit the ball starting from this height, and the ball will travel this direction. It will go over the net, and then it will land 6 meters past the net. Okay. So I had to think about that a little bit myself just to get in my head what they were describing. Okay. So again, our net is here in the middle, and the ball will be traveling this direction. Okay. Um, so we want to know at what height we are going to have to hit the ball in order for it to pass over this 0.9 meters by net. Okay, so again, we need to recognize that we have two triangles. I have a large triangle. Here's my large triangle. And then I have my small triangle right here. So I'm going to set this up so that I have my height of my small triangle is relating to the horizontal base of my small triangle. So that's the height of my small triangle relates to the base horizontal length of the small triangle. And that is set up equal to the ratio of the height from which I'm going to hit the ball and that triangle length as combination. It's not just 12, it's 6 plus 12. So that's a length of 18 on the base of the large triangle. So the height of the large triangle relates to the base length, horizontal length of 18, the large triangle. Okay, so let's get rid of some of these extra circles there. And now that we have a ratio equal to a ratio, that is a proportion, which means that we can now cross multiply. We cross multiply across an equal sign. Okay, so I've got 6 times h is equal to 0.9 times 18. And then I'm going to divide out the 6 on both sides. The 6's, of course, cancel out. And so h, the height from which the ball must be hit, is going to be equal to this calculation. And I get my handy dandy calculator and I see that 9 times 18 or 0.9 times 18 is equal to 16.2. And then 16.2 divided by 6 is equal to 2.7. So the height is going to be 2.7 meters. That is the height from which I must hit the tennis ball. 2.7 meters is the height from which we will hit the tennis ball. From which we will hit the, okay, so my writing's getting weird here. Hit the tennis ball. Tennis ball. Okay, so hopefully that makes sense, how to set up your ratios and how to calculate the answer for that. Okay. This next problem shows two triangles which are rotated in different directions from each other, but they are similar triangles. Because we've got this angle right here that is noted that it is congruent to this angle. And of course, these two are vertical angles, and vertical angles are congruent. And if 1, 2, 3, 4, 4 of those angles are congruent, then the other angle has to be congruent. So that confirms that they are similar triangles. Okay, so we know they're similar triangles, and we know that our corresponding sides will be proportional to each other. So I'm thinking about this in terms of the outside side and the outside side, or the opposite. I think I called those opposite. Yeah, opposite here. So this is the side that's 7 inches, and the side that is the mystery X. Those are the opposite sides, and they are noted here by 7 and X. And then we also have what I'm calling the inside side. So we've got the side that's 5 inches and the side that is 8 inches. So again, the inside are 5 and 8. And we have to understand that the small triangle has to do with the 7 and the 5. So the small triangle is the 7 and the 5. And let's go to a different color here. La, la, la. There we go. Okay. So, and then the large triangle has to do with the 8 and the mystery X. So the large or big triangle has to do with the mystery X and 8. So anyway, now that we've got our ratios set equal to each other, we now have a proportion, and that means that we can now cross multiply. So I can cross multiply across the equal sign, and that's going to be 5x is equal to 7 times 8. And then we can divide out the 5 on both sides. 5s will cancel right here, and then x is going to be equal to that calculation. And if I look at my handy dandy calculator, it says that 7 times 8 is equal to 56. And 56 divided by 5 is going to be 11.2. So 11.2 is the mystery side measurement, mystery side measurement of the large triangle, of the, or I'll say big to save some letters here, big triangle. Okay. This last problem tells us that we have a building cast a 103-foot shadow at the same time that a 32-foot flagpole cast a 34.5-foot shadow. And it wants to know, how tall is the building? Okay, so these things always are helpful if we draw ourselves a picture. So I've already drawn kind of sort of a picture here. I didn't want you to think you wanted me to freehand it because I'm not the best artist. Okay, so there's our building, and it says that it has a 103-foot shadow. So that is the 103-foot shadow. And of course, the questions they're asking is, how tall is the building? So there's the mystery. The height of the building is the mystery. And we also have another situation where they say the flagpole is 32 foot tall. So they actually do tell us what the flagpole height is. It is 32. And the shadow of the flagpole is the 34.5. So we can set that up and we can relate um, the height of the building to the shadow of the building, and that will relate to the height of the flagpole to the shadow of the flagpole. So went ahead and have it written up here. So I think that's what we did. Yep, the height. So both of these are related to the building. Here's the building. And both of these are related to the flagpole. Okay. And now that we've got a ratio equal to a ratio, we can cross multiply. So we could do h times the 34.5 and 103 times the 32 feet. So let's see, 34.5 h is equal to 32 times the 102. And then we're going to divide out the 34.5 on both sides. And then all those 34.5s are going to cancel there. And then h is going to be equal to that calculation. And we're going to use our handy dandy calculator. So 103. Can I write that down? Yes, I wrote that down wrong. It was supposed to be 103 right there. So 103, not 102. 103 times 32 is equal to 3,296. And that number divided by 30.5 equals 95.5. So 95.5. And we're talking about feet. So it's going to be feet. So that's how tall the building is going to be, 95.5 feet tall. Okay. So hopefully this helps you understand the process of finding missing measurements between similar triangles and how that it relates to real life situations. And we just hope that you'll come back for more math information. Just click on the subscribe button, click on the like button, and we'll see you another day.